Good day, everyone. Today we are going to continue our learning about scheduling strategies. So there are two algorithms that we are going to cover. They are the clock-driven scheduling algorithm and also the priority-driven scheduling algorithm. So for the clock-driven, we are using round-robin approach as our example, while the priority driven we are going to use the RM, the rate monotony, and DM, the deadline monotony algorithm. So as you can see from our name, so priority driven, that means we are going to set the priority according to the algorithm requirement. So there we are going to explore a little bit. So basically, in short, that the rate monotony is based on the period. So the shortest the period, or we can show the lowest, the shortest the period. Okay, so the highest the priority that we are going to given. Okay, so while the deadline modeling, so obviously is based on the deadline. So again, the shortest the deadline, so the higher the priority. So these are basically the algorithm they are focused about. So again, in our scope, we focus about the uniprocessor based. This means that only one task can be executed at any point in time on the processor, because only one processor. Okay, compared to your smartphone, they may be have 8 core. This means the 8 processors they can doing 8 tasks at the same time. So but for the Arduino, for example, it's a uniprocessor. That means you only can do one task at a time. However, you might always that there are several things occur at the same time, because it's a microprocessor. Everything occur in microseconds. So in 1 second, a lot of things can happen. So it can appear doing a lot of things at the same time, but actually they process differently, sequentially. So scheduler, the task for scheduler is to assign which one should be occupy the CPU, just like what I show you in the previous video. So I was scheduler, because I determine which task, okay, should go to running stack. That means they occupy the CPU and so on and so forth. So I was scheduler, okay, to schedule the task. And then there are two things you can describe, or you can use to describe the scheduler, whether they are valid or invalid. Invalid means that it can be under schedule or over schedule task. So a task that is considered over schedule, that means you give too many time to work. Okay, you assign more time than needed for execution. So this means you wasting the resources. Under schedule, on the other hand, that means there's insufficient time for it to be completed, so it's under schedule. So a scheduler consider valid. This means you should avoid both under and over schedule. Okay, just like you schedule yourself to study a task or to study a subject, so make sure you have sufficient time. And at the same time you are no over study that subject. Okay, to be valid. So next is again some terminology that you might be used to describe your project. So first is the feasibility or feasible. Schedule is said to be feasible is if every task schedule complete before its deadline. So it's feasible. Okay, basically feasible is trying to describe schedule. So this schedule feasible or no? Okay, how you design your schedule for your semester? Is your schedule feasible or is invalid? Okay, so this is something that we use to describe schedule. Okay, schedulable is describe the system, a system, whether the system is schedulable. Okay, how you know whether the system is schedulable means that the system has feasible schedule. Okay, if a system have a feasible schedule, that means this system is schedulable. Okay, next is about optimum. Optimum we use to describe an algorithm. Okay, the RM algorithm is optimum. It's not optimum actually. Okay, because it's not always produce feasible schedule, but sometimes it do produce the feasible. So to have an optimum schedule is quite tough. Okay, So to try to link these three new terminology, so we can use this block diagram. So basically we can say the algorithm produce schedule. Okay, algorithm produce schedule. Okay, whether you are using the RM, the rate monotonic algorithm, or the DM, so you produce a schedule. Okay, so this schedule will be used for a system. Okay, a system, of course there are several tasks, task 1, task 2, task 3, task 4, and so on and so forth. Okay, so it's going to set which one has higher priority. For example, which one will be executed. Okay, so this is the first one, algorithm produce schedule to a system. Okay, next, if we have an optimal algorithm, so optimal algorithm will produce feasible schedule. Since we produce feasible schedule to a system, so the system is schedulable. Okay, so that's all, quite straightforward. I mean, there are three relationships, so try to use this diagram to imagine this their relationship.